Welcome to A1 Tutor live class and welcome to the physics class. We've started a topic this week in physics, which is gas law. And in the first class, we discussed about the atmospheric pressure. We're able to make justice to the concept of atmospheric pressure, and also we're able to explain some facts about atmospheric pressure, how measurement is being taken in a barometer. We also explained that how measurements are being taken using a barometer. And today we are going to go into calculation. Like I said, we'll be focusing on the Gay-Lussac law, the Charles law, and the Boyce law. And majorly, we'll be dealing with calculations. Majorly, we'll be dealing with calculation. But before we go into the calculation, we are going to consider the law. We'll be stating the law and express them mathematically. We'll be stating each of these laws, the Gay-Lussac law, the Charles law, the Boyce law, and we are going to express them mathematically. Then we'll go ahead to use the mathematical expression of each laws to solve questions. That has to do with UTME question on this topic, gas law. So we have Charles law, Boyce law, and Gay-Lussac law that we're going to be considering today. Let's start with the law, stating out the law and expressing them mathematically. We are still under the topic gas law, and today is part 2. We are considering gas law part 2. In the first part, we discussed about the measurement of gas. We discussed about the barometer. We also discussed about the concept behind using the instrument called barometer. We also discussed about the instrument, the nanometer. We also discussed about that instrument used for measuring gas and the instrument used for measuring the pressure, which is what? The barometer. The manometer, which is used for measuring gas, and we also deal with the atmospheric pressure, which is measured by the barometer. So today we're going to go into the calculation in full, but we need to first consider the law, because the law are going to give us an hint on how to deal with the calculation of today. So if perhaps you are not chance of joining the class, the last time we had a class, the previous lessons, if you're not joining it, you can do well to visit the A1 Tutor page on YouTube. The videos are available on the channel. The videos are available on A1 Tutor page on YouTube. So you can go there and watch the first part of gas law. The first part of gas law. And other videos also are available there. So you have access to almost like 98 videos that have been covered during this live session. And you can do well to watch them and drop your review and also drop your comments. Don't forget that subscribing to the channel will make it easy for you to receive notifications of the videos when they are being uploaded. So back to today's business, we are treating gas law part 2, and I said we'll be starting with stating the law, and we'll be starting with Boyce law and the Charles law. Boyce law and Charles law. This topic is a topic that is actually in chemistry also. So peradventure you've done it in chemistry or you've not, it's almost the same thing. There are no differences. You'll be doing this in physics and also in chemistry. So the knowledge is the same. Boyce law, then Charles law. What is Boyce law stating? Boyce law states that the pressure of a gas take note of the word, the pressure of a gas is inversely proportional to its volume, provided that the temperature remain constant. The pressure of a gas is inversely proportional to its volume, provided the temperature remains constant. Let's express that mathematically. Boyle's law states that pressure is inversely proportional, that is 1 over volume. Pressure is inversely proportional to its volume, provided that the temperature remains constant. So the constant in this is the temperature. The temperature has to remain constant in Boyle's law. Temperature has to be constant in Boyle's law. So expressing this mathematically, we have it as P varies inversely proportional or varies inversely as 1 over V, which is expressed as P is equals to introducing the constant, which is going to be T. The constant here is the temperature, T over V. T over V. So we have this over 1 by cross multiplication, you're going to have PV equals to T. PV equals to T, saying that the pressure is proportional to the volume, provided that the constant, which is T, provided that the temperature is what? Constant. The temperature is constant. So this implies that PV will be expressed as 1V1 equals to P2V2, provided that the temperature remain constant. I will have PV equals to T, which is expressed mathematically as P1V1 equals to P2V2. That is, the force pressure multiplied by the force volume is equals to the second pressure given multiplied by the second volume. So this is the mathematical expression of Boyle's law. P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. Now let's look at that of Charles' law. What does Charles' law state? Charles' law states that the volume of a gas is directly proportional. Charles' law, the volume of a gas is directly proportional. That is, varies directly proportional. Still the same meaning. It still connotes the same meaning. Varies directly proportional. The volume of a gas is directly proportional to its absolute temperature. So volume is directly proportional to temperature. Volume is directly proportional to temperature, provided that the pressure remain constant. Provided that the pressure remain constant. Underline the word, the pressure remain constant. So expressing this mathematically, we have V equals to K. Instead of using K, in mathematics we use K to represent constant. But now, because we are dealing with physics and the law says that the pressure remains constant, so we're going to use P instead of K to replace the constant. So I'm not going to be using K, I will use P rather, because P remains constant here, and we have T. Expressing this in terms of what? P, which is the constant, we have P equals to, dividing both sides by your T, P equals to V over T. P equals to V over T. P here represents the constant, take note. So the pressure equals to volume over temperature. The pressure equals to volume over temperature. Because the pressure here is constant, remains constant. So Charles' law will now be expressed finally as V1 over T1 is equals to V2 over T2. We are making use of this expression. V1 over T1 is equals to V2 over T2. So this is the mathematical expression of Charles law, the mathematical expression of Charles law. Take note, in your CBT questions, you can be asked, they will state the law of Boyle's law, probably Boyle's law, Charles law, and they will ask, what remains constant in Boyle's law? You should know that the temperature remains constant in Boyle's law. The temperature remains constant in Boyle's law. And in Charles law, the pressure remains constant. The pressure remains constant in Charles law. So you have to take note of those keywords in the law. You have to take note of it because questions can be coined out of those statements. In Boyle's law, the temperature remains constant, and in Charles law, the pressure remains constant. The pressure remains constant. So this is for Boyle's law and Charles law. Let's consider Gay-Lussac law also. That's another law under the gas law, Gay-Lussac law. Gay-Lussac. Gay-Lussac law. Let's see what the law says also, the law of Gay-Lussac. Gay-Lussac law. So Gay-Lussac law states that the prior Lussac is double S, double S, Gay-Lussac law. So Gay-Lussac law states that the pressure of a gas is directly proportional to its absolute temperature. To its absolute temperature, it states that the pressure of a gas is directly proportional to its absolute temperature, provided that the volume remains constant. Pressure is directly proportional to its absolute temperature, to its absolute temperature. When you hear the word absolute temperature, that is the temperature we are going to be using under Gay-Lussac and the Charles law, they cannot be negative. They are always positive. The word absolute gives us that, tells us that the temperature is a positive value. The temperature is a positive value, not a negative value. Of course, you have a negative temperature, but for the case of this topic, Gay-Lussac law and the Charles law, the temperature is set to be an absolute temperature, which is a positive temperature. So if pressure varies directly to the temperature, provided that the volume remain constant, that is, P will now be equals to, introducing the constant is V, which is the volume. We have VT, and making V subject of the formula, that implies that we'll be dividing both sides by T, and V will now be equals to P over T, which is expressed as P1 over T1 is equals to P2 over T2, provided that what? The volume remain constant. Provided that the volume remain constant. Provided that the volume remain constant. Now, with these three laws we've discussed, you'll be able to see that we have three distinct things that differentiate them. Starting with Boyle's law, the Charles law, then the Gay-Lussac law, In Gay-Lussac, volume is constant. In Gay-Lussac, volume is constant. In Gay-Lussac, volume is constant, while in Charles law, the pressure is constant. The pressure is constant. In Charles law, the pressure is constant. And in Boyle's law, the temperature is constant. The temperature. So take note of this summary. In Boyle's law, the temperature is constant, or the temperature remain constant. And in Charles law, the pressure remain constant. And in Gay-Lussac law, the volume remain constant. The volume remain constant. So this is a summary that will really help you. Questions can come around this particular summary. You should be able to know what remains constant in each of those laws. Boyle's law is temperature remain constant. Charles' law, the pressure remain constant. And for Gay-Lussac, the volume remain constant. All right, so that is very important for you to take note of. Now let's go on to take questions now that has to do with these laws we've discussed. Charles' law, the Boyle's law, and the Gay-Lussac law. We're going to be solving questions on it, questions on this particular we're going to be taking questions on this law. So we'll be starting with the first question. The first question. Question on gas law. Question on gas law. So let's go ahead to solve the first question. The first question. A gas exerts a pressure of 150 kilopascal. A gas exerts a pressure of 150 kilopascal in a container with volume 5 meter cube. With volume 5 meter cube. If the volume is reduced to 3 meter cube at constant temperature, what is the new pressure? What is the new pressure? To solve this, we need to write out the parameters in the question. We are given pressure, that is the first pressure in the question, denoted by P1 equals to 150 kilopascal. K is kilo, while PA is pascal. Pressure is measured in pascal. Pressure is measured in pascal. In a container with a volume, so the first pressure, the volume of that is 5 meter cube. That is V1 equals to 5 meter cube. Always take note, if your volume was given in centimeter, you are going to convert it from centimeter cube to meter cube before you can solve the question. Because in physics, the unit for length is meter, and the unit for area is meter squared, and the unit for volume is meter cube. So if you are given anything different from meter cube, you need to convert it to meter cube before you can proceed to solve the question. So if the volume, we are given this as the first pressure, then this the volume. Now, if the volume is reduced to 3 meter, another volume was given, that is V2 is equals to 3 meter cube at a constant temperature. At a constant temperature, what is the new pressure? What is the new pressure? The new pressure is P2. The new pressure is P2, which is what? Unknown. The new pressure is unknown. So we want to solve to get the new pressure. And to do this, we are going to be using the formula of Boyle's law. This question is under Boyle's law because the temperature remain constant is part of the statement of Boyle's law. Boyle's law states that the temperature remain constant. So when you see this in your question, it directs your mind to Boyle's law. And what is Boyle's law? Mathematically expressed is expressed as P1 V1 is equals to P2 V2. Now, to make this solving very easy, you have to make what you are looking for, that is the missing parameters, which is P2, the subject of the formula. You have to make P2 the subject of the formula. And to do that, you apply your knowledge of mathematics to make P2 the subject of the formula. You have to divide with anything you have beside P2. You have to divide with anything you have beside P2. So beside P2, I have V2. So I'm going to be dividing both sides by V2. Dividing both sides by V2. Divide both sides by V2. That will give us P1 V1 over V2 equals to P2 V2 over V2. V2 cancel out V2. We have P2, which is the second pressure, is equals to P1 V1 all over V2. So with this, we can get the value of what? P2. After getting it, we are going to check the options given to us and pick the right answer. So we have P2 now to be equals to P1 is given to be 150 kilopascal. That's 150 multiplied by V2, which is 5 meter cube, all over V2, which is 3 meter. So we have to simplify this. We have P2 equals to, if we have 3 here, cancel, we have 1. 3 and 15, that is 5. That means we have 50 multiplied by 5. 50 multiplied by 5. P2 will now be equals to 250. 250 kilopascal. Now, the reason why I have to use kilopascal is because the unit of pressure given in the question initially was kilopascal. If the unit was given to be millimeter mercury, my answer also would be in millimeter mercury. But because the question was given in kilopascal, I have to also express the final answer in kilopascal. So we got P2, which is the second pressure, to be 250 kilopascal. Now let's examine together the options. Option A is not the answer. Option B is the answer, of course. Option B is 250 kilopascal. Option B is 250 kilopascal. So this is how you are going to solve questions related to this kind of questions when you are given that in your UTME. Very easy to solve. First, write out your parameters. When you are done with that, you are going to identify what you are actually looking for. And once you know the parameters you are looking for, you make that parameters the subject of the formula. You make the parameters the subject of the formula. So this is going to give us P2 equals to 250 kilopascal. Now let's look at the second question, still under gas law. The second question under gas law. You permit me to wipe the board. Second question, still under gas law. Still under gas law. I will go for the second question. The second question. The pressure The pressure of the gas is the pressure of the gas is 500 millimeter mercury. Now, this is what I was trying to explain the other time. Now, the unit of pressure here is no more kilopascal, but it is millimeter mercury. Pressure is also measured in millimeter mercury. It is also measured in kilopascal. But for this question, we are working with millimeter mercury. Millimeter mercury. The pressure of the gas is 500 millimeter mercury. Underline 500 millimeter mercury. That's the first pressure given in the question. When its volume is 4 liters. When its volume is 4 liters. So we have the volume to be 4 liters. If the volume changes to 2 liters, we have another volume given. The first volume was 4 liters and the second volume was 2 liters. At constant temperature, what is the final pressure? What is the final pressure? What is the final pressure? So let's identify the parameters. P1 given to be 500 millimeter mercury, and we are given V1, which is the first volume, as 4 liters, 4 liters, and also V2, which is the second volume, given as 2 liters, and we are asked to find the final pressure. The final pressure is P2, which is unknown. The final pressure is unknown. The final pressure is unknown. To solve this, like I said, is better or is easier or convenient. It is convenient to make P2 the subject of the formula, and which we've done in the previous solving. So P2 was given as P1 V1 divided by V2. P2 now should be equals to P1, which is 500 multiplied by V1, which is 4, divided by V2, which is 2. Now you will see that the volume was given in liters, both in liters. So there's no need of conversion. Had it been we are given the first volume to be in liters and the second volume to be in meter cube, that means we need to convert to ensure that they have the same units. But both are in the same unit already. They are both measured in liters, liters. So there's no need of converting there. So far, they have the same units. So take note, if you are given questions and the volume is in the same unit, the first volume and the second volume are in the same unit, you can go ahead to solve. If the first pressure and the second pressure is having the same unit, you can go ahead to solve. Or if the temperature has the same unit, you can go ahead to solve. But if they have different, probably P1, the unit for P1 is different from the unit of P2, then you need to convert so that both P1 and P2 can have the same units. Same thing is applicable to the volume, and same thing is applicable to the temperature. The same is applicable to the temperature. So for this, we have 2 divided by 2, that is 1. 4 divided by 2, that is 2. We have P2 to be equals to 500 multiplied by 2. 500 multiplied by 2. P2 will be equals to 1000 millimeter mercury. 1000 millimeter mercury. Because the first pressure was given in millimeter mercury, the second or the final pressure also should be in millimeter mercury. So the response is 1000 millimeter mercury. Let's check the options together. Option A is 250 millimeter mercury. That is not the answer. Option B is 500 millimeter mercury. That is not the answer. Option C is 1000 millimeter mercury. So option C is the correct response. And option D is not also the answer. So option C is the correct answer. 1000 millimeter mercury, 1000 millimeter mercury, 1000 millimeter mercury. Now we're going to take another question again. We are still under solving questions on gas law. Solving questions on gas law. Let's consider the next question. The next question under gas law. Let's consider the next question under gas law. The next question under gas law. The next question. So we have the next question to solve, still under the topic gas law. The topic gas law. The next question we are going to be solving. A gas has a pressure 300 kilopascal. 300 kilopascal at 27 degrees Celsius as temperature. A gas has a pressure of 300 kilopascal at what temperature? At 27 degrees Celsius temperature. If the temperature is raised to 127 degrees Celsius at constant volume, what is the new pressure? At constant volume, what is the new pressure? What is the new pressure? Now, if you check the question, you are given your temperature to be in degrees Celsius. Your temperature was given in degrees Celsius. And if you are solving this, the temperature have to be in Kelvin. The temperature have to be in Kelvin. In gas equation, the temperature should be in Kelvin. So we need to convert the temperature to Kelvin. We will need to convert the temperature to Kelvin. And that's the first thing we'll be doing. We have T1. The first temperature stated in the question is 27 degrees Celsius. 27 degrees Celsius. Converting that 27 to Kelvin, we are going to be adding the standard temperature, which is 273. 273. Add 273 to 27. Add 273 to 27. The answer should be 300 Kelvin. 300 Kelvin. And for T2, we have the second temperature to be 127 degrees Celsius. Also, adding the standard temperature, which is 273, we are going to be having 400 Kelvin. 400 Kelvin. We have to convert from Celsius to Kelvin. And to do that, we'll be adding 273, which is the standard temperature. The standard temperature. So we have T1 and T2 already. And in the question, we are given P1 to be 300 kilopascal. 300 kilopascal. And I'm asked to find the new pressure. And of course, the new pressure is P2, which is unknown. P2, which is unknown. So we have P2 to be expressed as, we have to make P2 subject of the formula. P2 subject of the formula. And that we need to state out the law. Now, if volume remains constant, that means we are talking about Gay-Lussac law. We are talking about Gay-Lussac law. And Gay-Lussac law states that C1 over P1, or P1 rather, P1 over T1, P1 over T1 is equals to P2 over T2. P1 over T1 is equals to P2 over T2. Now, making P2 subject of the formula, we need to cross multiply. That will give us P1 T2 equals to P2 T1. Dividing both sides by T1, we are going to be having P1 T2 divided by T1. So P2 will be equals to P1 T2 divided by T1. That is, you divide this side by T1, divide this side by T1. T1 here will cancel T1. So P2 will be expressed as P1 T2 over T1. Substituting the value into this formula will land us to the final answer straightforward. Will land us to the answer. So we have P1 given already in the question, 300 kilopascal multiplied by T2, which is the Kelvin, 400 Kelvin, divided by T1 in Kelvin, that is 300 Kelvin. P2 equals to, if 300 cancel 300, we have P2 to be equals to 400 kilopascal. 400 kilopascal. So the value of P2 is 400 kilopascal. 400 kilopascal. That is the value of the final pressure. The value of the final pressure is 400 kilopascal. 400 kilopascal. So this is how we get the answer for this question. Now let's check the options if our answer is there. Option A is 400 kilopascal. That implies option A is going to be the correct answer, while option B is not correct. Option C is not correct, and option D is not correct. The correct option is A, which is 400 kilopascal. 400 kilopascal. We'll take another question again. We'll take another question. We've been able to solve a question on Boyle's law, a question on Gay-Lussac law. Now the next one we'll be taking will be a question on Charles law. Will be a question on Charles law. But before that, let's take a pause and address our fans who are following us on YouTube. Thank you all of you who have been subscribing to our YouTube channels and also who have been following our videos on YouTube. Thank you for watching and thank you for subscribing. But perhaps if this is the first time that you are watching our video on YouTube, we want to tell you that you can subscribe to the page of A1 Tutor to facilitate you receiving notifications for our videos. So if this is the first time you are watching this video, watching A1 Tutor videos on YouTube, do well to click on the subscribe buttons so you can have access to notifications of our videos. Do not just click on the subscribe buttons, click also on the notification bell, and do well to comment, like, and share our video. And perhaps after you have watched this particular video and you have questions to ask, do well to drop your question in the comment section. And of course, we are going to get back to you by giving the response to your question. So if you have question based on this video, do well to drop your question in the comment section. Do well to drop your question in the comment section. Okay, now let's continue now to another question that will lead us to Charles law. Charles law now, a question that will lead us to Charles law. A question that will be under Charles law. All right, okay, we have a question that will lead us to the Charles law we discussed earlier. Charles law. We are still solving questions on gas law. Solving questions on gas law. We've done a question on Boyle's law, a question on Gay-Lussac law. Now we are taking another question that has to do with Charles' law. That's to do with Charles' law. Let's have our question on the screen. Charles' law. So we have the question: a gas occupies a volume of 6 meter cube, a volume of 6 meter cube. Underline the key points: 6 meter cube, which is the volume, at a pressure of 400 kilopascal. The first pressure is 400 kilopascal at a temperature of 27 degrees Celsius, at a temperature of 27 degrees Celsius. If the pressure remain constant, if the pressure remain constant, if the pressure remain constant, if the pressure remain constant and the temperature increases, that means you have a new temperature, which is 127 degrees Celsius, and the temperature increases to 127 degrees Celsius, what will be the new volume? What will be the new volume? Let's list out the parameters, writing out the parameters in the question. We have volume that was given in the question, that is V1, it is 6 meter cube, and we are given P, which is the pressure, 400 kilopascal in brackets. A condition was stated that the pressure remain constant. So I'll write that in the brackets. The pressure remain constant. And again, we are given the temperature. The temperature, when the volume was 6 meter cube, the temperature was 27 degrees Celsius, and the temperature increases to 127 degrees Celsius. T2 is 127 degrees Celsius. And the question is, what is the new volume? That is, V2 is equals to unknown. V2 represents the new volume that we are trying to solve for. The new volume that we are trying to solve for is V2. To solve this, we need to first convert the temperature from degrees Celsius to Kelvin, converting the temperature from degrees Celsius to Kelvin. So to do that, you have to add the standard temperature to it, which is 273 Kelvin, to both temperatures. So we have T1 will now be equals to 27 plus 273 Kelvin, which is now equals to 300 Kelvin. That's for the first temperature. And the second temperature, we have 127 degrees Celsius plus 273, which is also equals to 400 Kelvin, which is also equals to 400 Kelvin. Now let's proceed by writing the formula of Charles' law. Charles' law is expressed mathematically as V1 over T1 is equals to V2 over T2, provided that the pressure remain constant. Charles' law, provided that the pressure remain constant. And you want to make V2 the subject of the formula. When you cross multiply this, you have V1 T2 is equals to V2 T1. Dividing both sides by the coefficient of V2, which is T1, that is the variable beside V2. We have this will be divided as T by T1, and this also by T1. V2 will end up to be V1 T2 divided by T1. So this is the expression of the formula. To get your V2, we are going to make use of V1 multiplied by T2. All is divided by what? T1. V2 equals to let's substitute the values, the parameters given to us in the question into the formula. V1 is 6 multiplied by T2, which is 400 Kelvin. We don't make use of this degree Celsius, but make use of what? The Kelvin. Divided by the T1, which is 300 Kelvin, 300 Kelvin, by simple calculation, if I multiply 6 by 400, multiply 6 by 400, multiply 6 by 400, I'll have 2,400 divided by 300, and this will give us 2,400 divided by 300. That will give us 8. So 8 is now the new volume. The new volume is 8 meter cube. The new volume is 8 meter cube. The new volume is 8 meter cube. Checking the options, option A is the answer, while option B to D are wrong responses. So the answer is option A, 8 meter cube, 8 meter cube. So we've been able to touch questions on the Charles law, the Boyle's law, and the Gay-Lussac law. The three laws, we've been able to solve some questions on them. And I'm going to drop some questions as evaluation, which I want you all to solve and drop your response on YouTube. So I'll drop the questions for us so we can make use of those questions as practice question and do well to drop your response on YouTube. That is in the comment section. You can do well to drop your response there. So we'll be having like 4 questions to solve. 4 questions to solve. So these are the questions they are going to solve for me. You solve these questions and you drop your response in the comment section on YouTube. If you are watching this video online, solve these questions and drop your response on YouTube, and we are going to get back to you on those responses. Thank you for your time. Today, we've been able to cover up the last aspect of the gas law, and that will be the last aspect we'll be working with. Thank you so much for your time and your attentiveness. Remain online. The next class will start in few minutes time. Ciao. Ciao, 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 ciao.